So in this lecture I am going to explain what is Anova test. So what is the name of Anova? Anova test is analysis of variance. So variance means change in the statistical method, and this is used to test differences between two or more means. So means means the average. For example, there are 5 students in the class and 5 students have scored some marks. So average of the 5 students can be calculated by adding all these 5 students marks divided by 5. So that will be the average, or also in statistical language we can say these are the mean. This may be for the one group. For example, there is another section and there are also 5 or 7 students. Exactly same way we can calculate the average or mean of those data. So one group and second group, there is the within group and between the group, right? Group A and group B. So we can calculate the variance, means the changes between these two groups or within the group. So that's why Anova method is used. So it is similar to the test, means t-test, but the t-test is generally used for comparing two means, while Anova test is used when you have more than two mean to compare. So the difference between t-test and Anova test is the t-test that we use for there are two means, we can compare those two means, but we cannot compare more than two means. But in Anova test we can do that. So it means we come to know Anova as well as t-test. No difference at all, except that we can compare two, but here we can compare more than two. So how to perform one-way Anova test? Anova is based on comparing the variance or variation between the data samples to the variation within each particular sample. If the between group variance is high and within the group variance is low, these provide the evidence that means of the group are significantly different. So what is the meaning of this? I am just going to explain. It means starting with understanding the between group variance. Between group means one group within the group. One is within the group, one is comparing A group, B group, C group. There are three. Group means, for example, classes. Student of the class A, student of the class A means different section. Section A, section B, section C, we can compare like that. So this is the between. Variance means changes of the marks between class A section, class B section and class C section. If this is the one figure that we have calculated, and the second one is within the group, means only section A, we want to check the variance. If in case the group variance is a little bit higher than the variance within the group, it shows that there is a significant difference, otherwise not. So Anova terminologies, some of the important points we can consider while understanding Anova. What are those points? So there are some terms like key terms, important terms to understand. The first one is a factor. This is another term for the independent variable in your analysis. In a one-way Anova, there is the one factor, while the two-way Anova, there are two factors. So one factor and two factor. What is the meaning of factor here? Right? No, look at this. One-way factor. This is a simplest type of Anova which involve one independent variable. For example, comparing the effect of different types of diet on cholesterol level. So there are different types of diets are there, and what will be the effect of these diet on the cholesterol level? Will go up, high, low, these are the levels. But high low is the level or medium is the level. But what is this? This is factor. On the basis of this factor, we are going to calculate the level, right? Now, so this is one way. So one way or two way or two factor. This involves two independent variable, and this allows for testing the effect of each independent variable on dependent variable. So there are dependent variable and another is an independent variable. What is the effect of the independent variable on the dependent variable, that we will calculate with the help of two-way ANOVA. So if there is an interaction effect between the independent variable on the dependent variable. Next is level. These are the different groups or categories within the factor. So factor, we have decided that this is the factor we want to calculate the diet and cholesterol level. So diet or cholesterol level, that is the factor. Diet is the factor. For example, if the factor is the diet, right, and the level might be low fat, medium fat or high fat. These are the level, right? Another example, marks of the students. Marks of the student is a factor. One-way factor or two-way factor. One-way factor, this is like marks of the students are not going to depend on other things we consider. Two-way factor, marks of the students depends upon their attendance. Marks of the students depends upon their weather constraints. Like marks of the students also depends upon the commute time and how far their college or university is there. They need to go to the college and attend the classes, and also depends upon the teacher and the way of teaching of the particular subject in which they are studying, right? So these are the factors. But after the factors, they have secured very good grades, A grade, B grade, C grade, or fail in the class. So these are depending upon the way of teaching. These may be depending upon the weather constraints. These may be depending upon the attendance in the class. That is the two factors. ANOVA. Level we have understood. Good marks, A grade, B grade, C grade and D grade. These are the levels. So factors and levels, two terms that we have learned today. So next we have a response variable. This is the dependent variable or the outcome that you are measuring. Now what is the response of this? Whatever the result that is coming is the response. Response from the experiment. We have set some objective. We want to know something. So that is the response variable, right? So within group variance. So variance means change. This is the variance or spread of score within each level of your factor. The level we have, for example, 35% marks, 45% marks, 55% marks, 80% marks. So there is a gap between all these, maybe 10, 10, 10 and more than 10. So the gap means sort of changes. Changes mean the variance. Only within one group, section A, same subject. In that section A, there are some marks of the students and marks are changed. We can say all students in that particular section A, on an average they will score 70% marks. This we think, that is our assumption, which is known as HO, means H0, hypothetic. Now this is the variance or the spread of score within each level of your factor. Now factor we know, diet one example, Then factor we know, score, second example. Next, between group variance. Now, within group that we understood, section A, section B, section C. These are the different groups. This is the variance, means change or spread of score between the different level of your factor. Now, the factors may be different in the different groups. We want to compare section A, section B and section C marks. We consider that section A marks are 70% marks. Section B, if those are 65, section C maybe 80%. There is the gap between all these grades. That is the variance. How much variance is there? How much change is there? Anova test automatically evaluate statistically in Microsoft Excel. Grand mean. So grand mean the overall mean. For example, section A, section B, section C. In section A there are 15 students, section B there are 20 students, section C there are 25 students. Right? Total of all these students, there are marks actually. Total marks we will add, divide by number of total student is known as the grand mean. So grand mean is a big, not only with the one group, maybe with the all group. Overall result of the college, overall result of the university, overall result of the particular subject in the different section in the college. This is known as grand mean. So mean here mean average. Treatment sum of scale, right? So SS is also one of the term that we use in Anova test. So SS is sum of squares. So square of what? So there will be some mean, actual figure x minus mean. The square of these two and total of these is known as SS, sum of squares. This represents the between group variability, mean changeability. It is the sum of squared differences between group means and grand means. Now degree of variance, DF. So degree of variance means the degree of freedom or the number of values that have the freedom to vary when computing a statistics. For example, if you have n observation, n means maybe total 35 students, maybe you can say 40 students or 50 students in one group, for example, then degree of freedom for that group is n minus 1. That is the degree of freedom. Now mean square. So mean squares, MS. Mean square is the average squared deviation and it's calculated by dividing the sum of square by the corresponding degree of freedom. So SS we calculate first and divide by DF. So now we will calculate MS, which is known as mean square. F ratio, the one more term is there. This is the test statistic for ANOVAs and it is the ratio of the between group variance to within group variance. So between group variance means comparing A section, B section and C section. There may be some variation and we are coming that and comparing that variation to the within group variation. Within group means within one section there may be some average, there may be some variation also. If the between group variance is significantly large or big as compared to the within group variance, that F ratio will be large and likely significant. So this may be the result, right? In this way we will be able to know that on an average student score 65% marks. Hypothetically, we think first, but after testing, Anova testing, we come to know whether we were right or wrong. Whatever we were thinking, and after the evaluation of all these statistical data with the help of Anova technique, we are right or wrong, right? Alternative hypothesis. What is that alternative hypothesis? This is the hypothesis that there is a difference between at least two of group means. This is H1. There is a H0 as well. H0 is hypothesis, which is known as null hypothesis. Hypothesis is assumption actually. It's nothing. Hypothesis is not a very big word, but actually it's a very important word. The meaning of this is assumption. I assume that there will be 70% marks for this particular class on an average. This is my null hypothesis. But actually, after checking all the data and the marks, calculating the midterm and final and total evaluation, we found that it's not a 70%, it's a 60%. It means whatever the null hypothesis I had, I was assuming that 70% is the null hypothesis. On an average, my students will score 70, but they have scored 60. So that is my assumption. Null hypothesis is rejected. My assumption is rejected. When my assumption is rejected, it means this is non-null hypothesis, which is known as alternative hypothesis, H1. So H1, this is a hypothesis that there is the difference between at least two of the group means. Yes, there is the difference. And H0 is the null hypothesis. As I explained, this is the hypothesis that there is a known difference between the group means. We consider there is a known difference between the group means. The one group, class A, section A, and section B. I consider in another section, the professor is teaching to the student, and I'm also teaching to the student with the same subject. I know, like, if whatever the marks that I'll score around 70%, and in that class there will be 70%. This I'm assuming is H0, is the null hypothesis. But my assumption, my hypothesis will be rejected when, after the evaluation of everything with the help of Anova, we will find that there is more than 75% marks in another group. Now, next is the p-value. This is the probability of obtaining a test statistics as extreme as the one that was actually observed. Assuming that the null hypothesis, as I explained, H0 is true. If the p-value is less than the significant level, means 0.05, we consider this is a 0.05 is one value. Value means one significant level. If the p-value is less than this value, the null hypothesis is rejected in favor of the alternative hypothesis. In the example, for example, I'll cover this one. And if I found that the p-value is 0.268244, if we compare this p-value with this 0.05, so 0.05 is less and this is more. In practically, with the help of Microsoft Excel, and we start with the Anova test, and the result we find that the p-value is more than 0.05, right? Then it means H0 is rejected. It shows that there is a significant marks and significance difference in the marks of three groups: section A, section B, and section C. Now I'm just covering the application of Anova. So application of Anova means where this Anova test is useful in the real life. Anova is commonly used in agriculture research to compare the effectiveness of the different type of fertilizers, crop varieties, or farming methods. For example, an agriculture researchers could use Anova to find out if there are significant differences in the yield of several varieties of wheat under the same condition. Different variety of wheats are available. What is the yield of that? How much the output they are getting, right? Under the same conditions. So that can be checked with the Anova. Not only one, but also Anova method may be used in a manufacturing and quality control. Anova is used to determine if the different manufacturing processes or machines produces the different level of product quality. Now we want to check the quality standard. For example, an engineer might use it to test whether there is the differences in the strength of the product based upon the machine that produces it. The one machine they have bought, for example, in any manufacturing unit, they are going to make some productions of some units, maybe furniture or mobile phone, maybe mouse or keyboard or any other items. At the end, they just want to know the quality standards. So that can also be verified and checked with the help of Anova test. In the marketing research, we use Anova to test the effectiveness of the different advertising strategies. Lots of companies, or most of the companies that we find, maybe Amazon or maybe the local company we have, maybe Superstore we have, Fresco, lots of. So all these companies make some advertisement and advertisement strategy they opt. For example, a marketer, maybe a marketing manager, they could use a Anova test. Why? To find out whether the different marketing message have a significant impact on the consumer purchase intention. Whatever the marketing methods or strategies they are using, maybe FM radio, maybe personal selling, maybe through pamphlets, maybe through social media, Instagram, which method is more suitable, or whether all these methods or any one of the method is having the significant or very important impact on the consumer purchasing power or purchasing intention. Anova method is also used in healthcare and medicine, and it is used to compare the effectiveness of the different treatments or drugs. For example, a medical researcher could use Anova to test whether there are significant differences in recovery times for patients who receive different type of therapies. In the hospitals, in the healthcare sectors, lots of patients come and go, and the treatment will be done on the basis of some medicines they, or maybe some therapies they provide. So different types of therapies and same kind of a treatment. So which therapy treatment is more effective to cure the particular disease. This can also be evaluated with help of Anova test. Now let's consider one education sector as well. And Anova is used in educational research to compare the effectiveness of the different teaching methods or educational intervention. For example, an educator could use it to test whether the students perform significantly differently when taught with different teaching methods. One method may be the online method, second method may be the class participation, third method may be just giving other PPT presentation or something. Practicals. So which method is more suitable? So that can also be evaluated with the help of Anova method. Now, psychology and social sciences. Psychologists and social scientists use Anova to compare group means on various psychological and social variables. For example, psychologists could use it to determine if there are significant differences in stress level among the individuals in different occupations. Different occupations are there. Maybe in the construction work, maybe for those who are working in the telecalling industries, maybe ICBC. We can find some people are just working from 9 to 5 duty, and they are just on the phone, right? And they are just dealing and communicating and guiding to the clients who just met with an accident. So what will be the psychological effect on those particular type of jobs? And second, maybe on the other side, those employees who are working as a receptionist or as an admin, what will be the effect on that? And so Anova test is a very useful test to compare the effect on the mind of the individuals in the different jobs. Biology and environmental science. Biologists and environmental scientists use Anova to compare the different biological and environmental conditions. So for example, the environmental scientist could use it to determine if there are significant differences in the level of a pollutant in different bodies of water. So this Anova test is very useful and widely used in the different sectors. So the advantage, if we talk about Anova test, is comparing a multiple group. This is one of the biggest advantage. And this test has the ability to compare the means of 3 or more groups. Means mean the average of 3 or more groups. The one group A, section B, section C, section A group, A mean, B mean average, C average, and comparing 1, 2, 3, the average of all the groups that we want to compare. So that Anova test have a very good advantage, and this make it more powerful and flexible than if we compare with a t-test. T-test is exactly same, but compare only 2. But hey, this one compare more than 2, right? Maybe 3, 4 and more.